Hey there, moving into a little Algebra 1 material here. Going to solve some equations. Basically, solving equations is you're going to get a letter alone, and to get a letter alone, you're going to do the reverse order of operations. So remember how your order of operations were parentheses, exponents, multiply, divide, add, subtract. You're going to work backwards. You're going to get the epsilon and get rid of the adding, subtracting first, then the multiplying, dividing. You're going to go this way. So you can deal with the parentheses last. Now, a lot of you are going to go, I want to deal with the parentheses first here, and that would work perfectly fine. I'm going to show you in the next problem why you might not want to do that, but just to show you what I would guess a lot of you would do. We just practice combining like terms and distributive properties, so I bet there'd be a lot of people doing this. And this works great. I've taught it this way many a time. Get everything put together on the left. And then you got a little two-step problem after that. Right? You're going to get rid of the extra term, the added and subtracted term, which is this 18. Now it's a positive 18. If you got an extra 18 laying around, you subtract it. Negative 22 minus 18, negative 40. And then that's negative 4 times x, so to get rid of multiply, you do the opposite, you divide it. So you get x is positive 10. Negative divided negative is positive. Now what I'm trying to say is you could actually do truly the order of operations. You could get rid of adding, subtracting first, which would be this 10. You could have minus the 10 over and left everything else the same. So you'd add negative 4 on the outside, x minus 2, and then negative 32 on the right side. Then instead of distributing, you could say, hey, this is negative 4 times something, so I'm going to divide it. You would add x minus 2 equals positive 8. And now you just got to get the epsilon. There wasn't anything left outside the parentheses here, so I just got rid of them. So I'm just going to add 2, and you see you get the same exact thing. So you don't have to distribute. I know that's what we've done over the years, but you don't have to. So keep that in mind. Because on problems like number 2, it's going to be way more beneficial. Do it the second way I just showed you. Number 2's got a fraction. If you go to distribute, I know some of you love fractions, right? If you go to distribute, you're like, wait a minute, I got to do 2/3 times 5, and 2/3 times 7, and I end up with 2 fractions. Yeah, I started with 1. If I multiply, I got 2. I don't want 2 fractions. 1's enough. So rather than do that, get rid of the 2/3 first by moving it over to the 18. Now, this is a 2/3 in front of parentheses, so you can divide by 2/3. But if you can remember a little something about dividing fractions back in the day, you actually multiply by the reciprocal. 3/2 times 2/3 is 1. 3's cancel, 2's cancel. That goes away. It leaves you with 5x plus 7. Over on the right, you can make that a hard problem. You can make it an easy problem. You can multiply the tops and get 54. Multiply the bottoms and get 2, and then divide and get 27. Or I encourage you, if you have a fraction you're multiplying, if you can divide first, do it. Can you do 18 divided by 2? You're going to have to divide by 2 at some point anyways. You can either do it now. 18 divided by 2 is 9. What's 9 times 3? 27. Okay, so you can divide first. It makes it easier. It allows you to do more mental math. Now you're down to the 2-step. Subtract 7. Divide by 5. Keep in mind, you could be plugging, going back in and checking your answers. There's no reason to get these wrong on a test. You go back in and make sure they actually work. So take your 4, plug it in there, see what you get. 5 times 4 is 20, plus 7, 27. And then you got to be able to do 2/3 times 27. It better be 18. If I divide 27 into thirds, it's 9, right? There are 3 9s in 27. 2 times 9, 18. I'm going to have you give number 3 a shot. See if you got it figured out. Check your answer. See if you can get it. All right, see how you did? Subtract 8. Negative 12. Multiplied by the reciprocal, which is 4/3. Let's go away. And look, I can divide 12 by 3, so do it. 12 divided by 3 is 4. 4 times 4 is 16, but there's a negative there. Add 4. Divided by 2. So we should get x is negative 6. Hopefully you got that. You ran through a check. You felt good about yourself there. If not, no big deal. We got time. We're just refreshing you now. We'll get it figured out. A couple special situations. Sometimes variables will cancel. If they do, if you get a false statement, like 4 equals 5, the x's are gone, put no solution. Get a true statement like 0 equals 0, or 2 equals 2, 3 equals 3. Put all real numbers. Anything will work then. So let's see what that one on number 4. Number 4's got x's on both sides, so I guess I'm going to tidy up the right-hand side like we did in the past. I'm going to do the distributive property. So 2x minus 6, 5 plus 2x. Then you're supposed to gather the x's on the same side. So normally you move the smaller one, well, they're the same. And if you subtract 2x from one side, you got to subtract from the other, and notice that they go away. So they're not equal. So you put no solution on them. Okay. I want you to be careful. A different problem, not like that you might come out, let's just do something real different. Let's say I had something like 2x plus 8 equals 8. A lot of times kids will get 2x equals 0, and I think that's no solution. Let's realize that in that case, x is actually 0. If you divide by 2, what's 0 divided by 2? 0. So these special cases are only if the x's go away. If the x's don't go away, you're going to get an answer. Okay? So no solution would be something like, I've got $10 and I make $3 an hour. Jim's got $5 and he makes $3 an hour. After how many hours would be the same? Never going to happen. We'll look at something like this. I'm always going to be 5 more. Because if we're making the same amount, I start with more, I'm always going to have more. I'm never going to be able to make it equal. There'd have to be a different value in front, which in this case stands for slope, and that's chapter 2. Not yet. Okay? Chapter 5. So here I want you to put on your thinking cap, have you type in an answer, write down an answer. What would go into parentheses and make this problem so it had all real numbers as a solution? Some people might also say it's infinitely many solutions, but I like all real numbers because that says anything will work. Infinitely doesn't cover everything, so I like all real numbers here. Okay, so let's see if we can figure out what you would put in here. All right, here's my thinking on this one. I want to have a 4, right? So in order to get a 4, because I'm going to need, well, I could have something like 4 equals 4. So if I got 4 on the left and I had 4 on the right, that'd be great. I'm going to want the x's to be the same so they drop out. Like on the one above, I had a 2x and a 2x. So this one's got a negative 2x. So I need a negative 2x over here. So I guess I just put a 2x here. Does that give me negative 2x? And then I'd like that 5 to turn into a 4. That way I'd have 4 equals 4. So if I distribute this negative, what would I have to have here? So they got a 4. I think I'd have to have a positive 1, right? So I'd have 5 minus 2x minus 1, which turn into negative 2x plus 4. And those are the exact same expression. So that's all real numbers. No matter what you plug in, it's going to work. Okay? So that's what I got for that, 2x plus 1. Are there other answers? Did anybody else come up with anything else that could have worked? I don't think I could have, but hey, if you can prove me wrong, go for it. Let me know. That'll wrap up this edition. Thanks for watching. Have a great day.